So now the final example of 3D geometry. It says here that we've got a regular square-based pyramid, square-based, and it has a size of length 4 centimeters and a height of 10. So first of all, before we move any further, I should sketch this thing out. It's going to have a square base of 4, and that reaches a point at the top. And it has a height of 10. So that is going from the point in the center of the base up to the top, and that length is 10. And it's asking for the angle between a face and the base. So that is between a face and the base. To find the smallest angle, I can't be finding that angle there because it gets small. The angle gets I should be finding the largest angle here actually. The angle gets larger the further I move my point to the middle point here. And in fact, if I took the angle between the apex, the top of this thing, the base, and that point there, that would find the maximum angle. And that's really what I'm trying to find here. So before I move on, I should start labeling these, and I'll do that in red. I think that should be quite clear. So the point in the middle I'm going to call O for origin, this point M for midpoint, and this point H for the height. So I'm trying to find the angle HMO, and I'm going to call that point A, and maybe I don't need any other reference points at the moment. So to find the answer to A, the angle between a face and the base is the angle HMO. And what do I know from this triangle? If I were to sketch it out, that's M, O, and H. I know OH is 10. And I know also that OM is 2 because it's a half of the base, which is 4, so that should be 2. And I'm trying to find the angle here. So that's simply going to be the inverse tan of 10 over 2, which is approximately equal to 78.7 degrees if I did that on a calculator, 3SF. Okay. What about B? The length of a sloping edge. So that is going to be the length AH. And how do I find that length AH? So I'm trying to find AH. I could look at the triangle I could create from A, O, and H, and that would include the length AH, so I think that might be going somewhere. I'll sketch that out and see if I could find it from my sketch. So I'll label the points again. You should do this, by the way. You should always label your points when you're drawing a sketch, because otherwise it doesn't make any sense. So always get into the habit of doing that. You're trying to find the length AH. And what do we know from this? We know that OH is 10, and we've got to find the length AO. And if we know that this length is 2 and that length is 2, then that's going to be 2 root 2. It's the same sort of proportion that we've seen before. I shouldn't really need to calculate that again. And to find AH is just going to be the square of those two added together with a square root. So the AH value should be 10 squared plus 2 root 2 squared, which is 8, all square rooted, which is approximately 10.4 centimeters to 3SF. Right, here we go. Let's do the next one in pink, purple. There we go. So C, the angle between an edge and the base. So an edge and the base. An edge, I think, should be AH. So we're trying to find the angle between AH and the base, and that could be going to O. So it's the same triangle that I've got above actually, and rather than using the 10.4 because that's not exact, I'm going to be using these two values, which is 10 and 2 root 2. And I'm trying to find that angle there. So this is using tan with the opposite and adjacent. So I should be doing the arctan of O over H, which is 10 over 2 root 2, which is approximately, if I were to do that into a calculator, 74.2 degrees to 3SF. There you go. Okay, now your chance to have a go at those exercises.